All right, here we go. Question number 15 from our Precalculus homework number 11 in MyLab Math. We have another word problem. It says a satellite dish is shaped like a paraboloid of revolution. That means it's going to be parabolic in shape. The signals that emanate from a satellite strike the surface of the dish and are reflected to a single point, aka the focus. The focus is where the receiver should be located. It says if the dish is 12 feet across at its opening and 4 feet deep at its center, at what position should the receiver be placed? And then if we read down here, it says the receiver should be placed a certain number of feet from the base of the dish. And so we're looking for how high above the center of the dish the focus should be located. So what I've done is I've sketched a graph over here of what the problem describes. We have this dish, it's in the shape of a parabola. It said that it is 12 feet across at its opening. So if I strategically place the vertex at the origin, then the distance up here from the center to each edge will be equidistant. So it'll be 6 feet to the left side of the dish, and it'll be 6 feet to the right side of the dish. And remember the depth down to the vertex from where it opens down, that's 4 feet. Now somewhere along that axis of symmetry is where the focus is going to be located. Now, if you know anything about the way a parabola works related to satellites, what happens is signals come in from space, and when they strike the dish, they are reflected to a certain point. No matter where they strike the dish, they are always reflected to that single point. You know, even on this side, if it comes in shallow, it's still going to be reflected over. And that special point is known as the focus, which is what we're looking for. And so we're looking for this distance from the vertex up to the focus. Now, what do we know? We know some stuff based on the way I've laid out this parabola. I strategically located the vertex at the origin to make my calculations easier. Remember, the vertex is the ordered pair h comma k, and that's going to tell me that h and k are both 0. Now, I need another point on the parabola, and I'm going to choose this point right here. That's going to be pretty easy to find because from the center over, that's going to be a distance of 6 feet, and then vertically up, that's going to be 4 feet. And that would correspond to an ordered pair, 6 comma 4, and that's just going to be a generic xy, but it is on the parabola. Once I know these two pieces of information, I can then construct the equation of the parabola in standard form. Using my generic x minus, remember h is 0, squared equals. Now I don't know p, but I do know the y and the k. And that's going to allow me to solve for p. So this is going to give me 6 squared equals 4p times 4. 4 times 4 is 16. And then if I divide both sides by 16, that will isolate the p. And I believe that fraction will reduce. And I'm going to use my handy dandy class whiz to do that for me. Let him do the heavy lifting here. Reduced to lowest terms, my p is 9/4. All right, now keep in mind what we're trying to find here. We're trying to find the distance from the vertex up to the focus. So what we really need to find is the focus. And if we scroll up, knowing that we have a vertical axis of symmetry, we can see the focus is the ordered pair h comma k plus p. And again, think about this. I don't really need the ordered pair. It just wanted to know how far up should I locate the focus. And remember, how high is the y. So I really only need to find the y coordinate. Oh, and we know that K was 0 based on my choice of the vertex. So this y coordinate, this value that we're looking for, is simply 0 plus p. Well, guess what? It's just p. And that's going to be 9/4 feet. Now, I'm not sure if they want that as an improper fraction or a decimal. If this is real world stuff, you probably want a decimal. And coming back over here to the MyLab math, all it says type an exact answer. It doesn't specify a fraction or a decimal. So I'm going to go with the fraction, and that's going to do it for this problem. So if you have any questions or comments about anything I've covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.